lastly, we're going to look at some other alternatives for producing energy, ones you might not think of on an everyday basis. First, there's geothermal energy. You can have water trapped in fissures and faults. That's heated by the Earth's core, resulting in steam, also resulting in fun things like geysers and hot pots. Here is the Blue Lagoon in I'm not going to be able to pronounce it. It's in Iceland. We're going to go with it. Reykjavik? Maybe. This is a geothermally heated lake in Iceland that you can go swimming in. You can create power plants with this. The steam is again used to turn a turbine. The nice thing about it is you don't have to burn coal or oil or natural gas to create the steam, or use a nuclear energy source to create the steam. It's created by the heat in the earth. As you might guess, there is a geographic distribution for geothermal electricity. If you're familiar with the Ring of Fire, where volcanoes and other phenomena occur, basically if you're potentially having a volcano, you're potentially going to have geothermal as well. Right? So in the US, it's primarily in the west and in Hawaii, a little bit in Alaska there. There are some caveats. There is some naturally occurring carbon dioxide that escapes into the air. There's definitely a geographic distribution of power for this one. The carbon dioxide emissions range from 4 to 740 grams per kilowatt hour. Compare that to the 460 grams per kilowatt hour for natural gas, or 960 per kilowatt hour for the best coal-fired plants. So definitely better than coal, potentially better than natural gas plants. You can also use geothermal heating for your home. You have a heat pump, which you can use anywhere for indoor heating and cooling. And you have heat exchange pipes, which are buried underground, and an air handler, which is inside your house to circulate through the pipes. In Reykjavik, 95% of the buildings are heated geothermally. Here is a heated municipal swimming pool because they have enough energy left over that they could do that. There's also tidal power, where ocean waves move baffles. The baffles move the turbine to generate electricity. It's a consistent source, but it alters tidal patterns, and you have to be near an ocean in order to access it. So a geographic distribution once again. This is cool, happening in Australia. We found this article in the spring of 2014. So there's these pods that are attached to a system at the bottom here, and as the pod circulates with the moving of the water, it causes this pump area down here to move. There is a video down here on how this works. I will post this one for you guys to watch as well. Here is a display of the world of who's using renewable electricity by technology as a function of, or as of 2012. So for example, anybody using biomass, top 5 users are US, Brazil, China, Germany, and Sweden. They show green. So see all the green over here in the Brazil area? Wind is in blue, geothermal in brown. The yellow is solar thermal, but it is used to the type where you're heating the water, not just generating electricity directly. The orange is solar PV, so now we're using solar to create energy directly. Hydro is water. It's a different, darker blue than wind. So if you look, the US has a little bit of everything. PV is huge over in Europe and Northern Africa. Biomass and hydro are big in Brazil. Remember, we have the Amazon rainforest and river there, so it is potentially good for both of those. Other things you can do. You can have an electrically powered vehicle, in which case you have no emissions at the point of use. Here are some informations on some electric vehicles. You can have a fuel cell, which uses hydrogen gas, takes in hydrogen and oxygen and produces water and energy. The nice thing is that they power an electric motor, and there are no CO2 emissions produced at point of use. However, there is water and potentially water vapor. Water vapor is also a greenhouse gas, though not as extreme as CO2. Here is the anatomy of a fuel cell. You have oxygen coming in up here. The cathode and anode are the electrical contacts that run the motor. So the oxygen comes in, the hydrogen's coming in the other way. This causes a flow, creating water out down here. So now the question is, where does the hydrogen come from? Because on Earth, most of the hydrogen is tied to oxygen in the form of water. So now we have to use energy to separate it by using a process called electrolysis. Water and energy come in, and you result with hydrogen and oxygen coming out. There's also the problem that hydrogen on its own is highly explosive. Another option for powering a car is biodiesel. So you take vegetable oils, react them with alcohol, and you produce a type of fuel that can power a diesel engine. Pure biodiesel B100 is non-toxic and biodegradable. You do get CO2 and other emissions as a result of burning them, but they're not necessarily as bad as the ones you get from burning petroleum-based fuels. So as with the last few chapters, think about the footprint. Think about the implications for soil, air, water, life. Think about the efficiency.